In this video, we'll be looking at 5 theorems that have to do with arcs and chords of circles. So the first theorem that we'll be looking at is a theorem that states that if we have a circle and we have let's use blue, and we have two chords and they make the two arcs, if that arc and that arc are the same length, then that chord and that chord will be the same length. So in order to have the same arc length, they have to be corresponding to the same length chords. So that's the first theorem we'll look at. So circles J and K are congruent to each other. And we also know in this example that this arc length is the same as this arc length. Because this chord is corresponding to that arc and this chord is corresponding to that arc, that means these chords have to actually be equal in length. So that is what we use to figure out what x is in this case. So we have here that 3x minus 7 is equal to 2x plus 1, and again we can do that because of the theorem I just mentioned. So we go ahead and solve this by subtracting 2x from both sides. We get here that x minus 7 is equal to 1. Now we can add 7 to both sides, and we get that x is equal to 8. So that's how you'd go ahead and use the first theorem. Let's look at the second theorem. Okay, so the second theorem that we're going to look at regarding our arcs and chords is this. Let's say we have a chord right here. If I have a radius or a diameter that's meeting this at 90 degrees, so it's perpendicular to my chord, that means that that radius or diameter is cutting this in half. So it's bisecting it. It's also bisecting the corresponding arc. So that's a given. So let's look at an example. Okay, so in our example here, it does not say that this side is equal to this side, but what we do know is that we have a diameter, and the diameter is perpendicular to our chord. So this is telling us, according to our theorem that we just learned, that this has to be equal to that, even if it's not shown. So now we know that 2x is equal to 4, and therefore x is equal to 2. All right, let's look at our third theorem. Okay, so this is very similar to our previous theorem. So here we see we have a chord right here, and it's being bisected by a line. Not only is it being bisected by this blue line, it's a perpendicular bisector. So if we see a perpendicular bisector of a chord, automatically it's a given that this has to be a diameter. That blue line is going to be going through the center of the circle. And now, since we've already done an example almost like this, I'm going to move on to the next theorem. Okay, so I know I said I had 5 theorems for you, but this is actually the fourth and last arcs and chords theorem that I have to show you today. So if you have two circles that are the same size, so two congruent circles, or you have one circle and two chords, if the two chords are the same length, then it is a given that they're going to be equal distance from the center. And when I say distance, I mean perpendicular distance. So the perpendicular line going from the center to that chord will be equal to the perpendicular line going from the center to that chord. So it's always the case. Two chords, if they're the same length, then they're going to be the same distance from the center. So in this example, we're being told that wx is equal to xy, which is equal to 22. As it turns out, we don't even need to know the fact that it's equal to 22. All we really need to know is that wx, well, we first need to know where w is and where y is. All right, so we need to know that wx and xy are two chords that are equal in measure. So since we know that those two chords are equal in measure, then they're going to be the same distance from the center. The red line here represents the perpendicular length from the center to that chord. So we know that it's 5x away from the center. And same here. AC is the distance away from the center of this chord, which means that since we know the distance has to be the same, that means 5x and 3x plus 4 is equal to each other. So let's write that down. All right, so now we can go ahead and solve our equation. We're going to subtract 3x from both sides. So we get that 2x is equal to 4. And we can divide both sides by 2 to get that x is equal to 2. So there you have it. It really wasn't a very hard question once you know that theorem. However, we did not actually finish answering the question yet, did we? We found x, but we did not yet find AB. So remember, AB is actually 5 times x. So it's 5 times 2, and the length of AB is 10. All right, great.